Trigonometry 1. We're going to start by looking at Pythagoras' theorem. Pythagoras' theorem deals with right angle triangles. If you call your straight sides A and B and your diagonals C, Pythagoras' theorem states that A squared plus B squared is equal to C squared. A beautiful theorem that you're going to use in a lot of different aspects of mathematics. So we set up a couple of triangles that you may have seen already. A lot of these triangles can be memorized. If we have a 3 and a 4 and we're looking for x, we say, well, let's do it the long way to begin with. We've seen the shorter way in coordinate geometry, but let's do it the long way to begin with. 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. 25 equals x squared. X is equal to the square root of 25. To get rid of the squared, you get the square root of both sides, so x is equal to 5. But the way I would like you to do these questions is, if you need the diagonal, we need the diagonal x, what we do is we get the square root of the two straight sides squared and added together. And if you just type that into your calculator, it will give you an answer of 5. So when you know the method in maths and all these shortcuts, that's how you become a good mathematician. So let's look at another one that works out evenly. So if we have a 41, a 9 and an x, so now we want, I'll do it the quick way in a minute like I've done here, but I'm going to do it the long way first. So there's two straight sides added together and squared is equal to the diagonal squared. 81 plus x squared is equal to,
according to Wikipedia, x are in America
1681. So now I need to bring the 81 across, and I'm going to have 1681 minus 81. So x squared is 1600. So x is equal to the square root of 1600, which is 40. Now, if we're looking for the diagonal, if we're looking for one of the straight sides, x, this was looking for the diagonal, we added. So when it's the diagonal, we add. So I would just say the opposite of add is when we're looking for the straight side, and these are the notes you should be taking in your copy, because the more you write this stuff down, the quicker you'll remember it. The straight side we're going to take away. So in this case, x is equal to the square root of the diagonal squared minus the straight side squared. So it's nearly the same, it's just the diagonal goes first, we have a minus, and if you type that into your calculator, amazingly, you're also going to get an answer of 40. So you choose which method you want to use. This is 100% correct. This is the best way to solve these problems. So now try the next three yourselves. One will be a straight side, the second will be a diagonal, and the third will be a straight side again. So pause the video and try these three questions. Solve for A, X, and Y. Okay, so hopefully you've followed the method I've shown you previously. Go back and look at it a second time. We're looking for the diagonal. We're looking for A. So we're going to add the two and square them and get the square root. And we're going to type it into our calculator. And A will give you 13. If you do it the long way, you're going to get 25 plus 144, which is 169. And the square root of 169 is 13. But to get good at maths, you want to find all of these shortcuts, which not are really shortcuts. They're just giving your brain extra knowledge that you don't need to show on the paper. So we need the straight side. So what did we say? We said it's a takeaway or subtract. 10 squared minus 6 squared. Now mathematically it's 100 minus 36, which is 64. And you all know the square root of 64 is 8. Now I threw this one in because a lot of people, when they see something they haven't seen before, they get confused. They say, I can't do it. Oh, we never did this before. But if you follow exactly the same method, we're looking for one of the straight sides. So which one have we looked for the straight side in? This one. What did we do? We wrote down x equals, this time y equals, the square root of 2 to be squared minus 1 squared. So this is a real test to get used to using your calculators. Use these brackets anytime you're squaring something. Put the squared on the outside. And if we type this into our calculator, we're going to get y is equal to 1. Now the reason is the square root of 2 to be squared is 2. And 1 squared is 1. So the square root of 2 minus 1 is the square root of 1, which you all know is 1. So that's why y is equal to 1. Now we're going to move on in this video and we're going to look at more what are called surds. And we're going to introduce angles that come up all the time in maths. So in this question, we're going to find x, then we're going to find the angle A, and then we're going to find the angle B using two different methods. So we're looking for the straight side. So if you want to pause it and give it a go, the diagonal squared minus the straight side squared will be equal to x. 4 minus 1 is 3, so x is equal to the square root of 3, or the square root of 3 is equal to x. It doesn't matter if you write the x on the left or the right. Now, let's look at angles in this case. So I'm going to introduce what's called SOHCAHTOA. And if you look at your calculators, you're going to see three things on your calculator. One beginning with the letter S, the letter C, and the letter T. Sine, it's dealing with angles, it's O over H, which we're going to see in a minute. Cos is A over H, and tan is O over A, and this will never change. SOHCAHTOA. So I just tell my students to remember this 9-letter words, practice saying it or spelling it. Sine is O over H, cos is A over H, and tan is O over A. Now, if we look at the angle A, I'm going to draw the triangle again. Here's the angle A. Now, slightly different. It's not drawn to scale. So it's the same triangle. And we have our root 3. We have our 1. And we have our 2. Now, labeling this triangle with 3 letters. The only 3 letters we have in these ratios are OH and A. And you can see it repeats OH and A for the rest of them. So H is always opposite the right angle. Another trick here is that H and A, when we're dealing with one angle, H and A always touch off the angle that we're dealing with. And if you remember that one simple thing, the last thing is that there's only one letter left, which is this side, root 3 will be O. SOHCAHTOA. So if we look at the sine of this angle, the sine of A is equal to, you go to your ratio, what is sine? O over H. O is root 3 and H is 2. Now that's what the sine of A as a ratio is, or as a fraction. Now to get the angle A, look at your calculators and look for your inverse sine. It's normally on top of the sine button, so you have to press shift or second function. So if you press shift sine, the inverse sine will come up. And if you put this in a bracket, root 3 over 2, and press equals, your answer will come up as 60 degrees. Now, let's do the same for cos. The cos of A is equal to, cos is equal to A over H. So A in this case is 1 and H is 2. And if we type into our calculators the inverse cos, pause the video and type it in, of 1 over 2, it's the same angle, so we're going to get the same answer, but just double check this on your calculator and get used to using your calculator. So this is introducing finding angles when we have all the sides. We've looked at Pythagoras as well. So let's look at tan. The inverse tan. Let me start with tan A. I don't want to jump too far ahead. Tan A is equal to, if we go back to our angle, what are our SOHCAHTOA? Tan is equal to O over A. O is root 3 and A is 1. So tan of A is root 3 over 1, which is just root 3. So if you type into your calculator the inverse tan of root 3, you know now at this point you're going to get 60 degrees. And these angles, these 60-degree angles, and well, what would be left in the triangle? Can you tell me what B is now? Can everyone identify what B is? If this is 90, this is 60, B has to be. The other two angles would have to be 90 added together because the three angles in a triangle are 180. B is 30. So we're going to look at these angles now with B, drawing the triangle, labeling it. So let's do that. Let's draw the triangle. B is at the top. Let's keep the positions the same. 2 is the diagonal, 1 was down the bottom, and root 3 was here. Now, if we're labeling our triangle, the only thing that changes when we label a triangle is O and A, because H has to be the angle, the side opposite the 90-degree angle. So H is not going to change. What did I say about H and A? They touch off the angle. And A means adjacent, so it's beside it. The person you live next door is adjacent to you. And then O is opposite. So labeling the triangle in these questions is key. So what would the sign of B be this time? We write SOHCAHTOA again, just so you don't have to go back up. SOHCAHTOA, sine is equal to opposite over hypotenuse, O over H. So the sine of B is equal to 1 over 2. And if we get the inverse sine of 1 over 2, you've told me what the angle is, you told me it's 30, you can see on a calculator, it comes up as 30. The cos of B is equal to A over H. Now you could write A over H off here to the side if you want to just then sub your answers back in. A is root 3, H is 2, and if you type into your calculator the inverse cos of root 3 over 2, you have to get the same angle. We're dealing with the same angle, 30 degrees. And similarly, the tan of B is equal to O over A to the side. O is 1, A is root 3, 1 over root 3, and you type into your calculator the inverse tan of 1 over root 3. There's a fraction button on your calculator, normally labeled AB. You will also get 30 degrees. So in the next lesson, we're going to see where these angles come from, dealing with the unit circle. So take notes from this video and make sure you understand the word SOHCAHTOA, what it means, how you label a triangle, and how to calculate the third side in a right angle triangle.